Hey everyone, and welcome to today's Explainer. Right now, we're setting our sights on the absolute bleeding edge of the tech world to uncover the hidden mechanics driving the trillion-dollar AI boom. Because, look, if we step past the everyday chatbot hype, there's actually an invisible, purely physical bottleneck that's holding this entire supercycle back. Today, we're looking at how microscopic physics is literally dictating global economics, and exactly how a game-changing technology called SisuSemi ALP enables AI growth.
Okay, let's just dive straight into the macro picture, because these numbers are absolutely staggering. If you look at the four largest US hyperscalers, we're talking Amazon, Alphabet, Meta, and Microsoft, they are guiding toward a mind-blowing 77% jump in their combined capital expenditure. We're going from roughly $410 billion in 2025 to a projected $725 billion in 2026. This isn't your standard corporate spending. This is a frantic global scramble by these tech giants who are completely terrified of being compute constrained.
So to really wrap our heads around that massive $725 billion figure, we have to recognize one simple fact. Artificial intelligence is no longer just a neat little demo. It's become vital global infrastructure. In under 3 years, AI evolved from a research curiosity into systems that are actively drafting legislation, triaging hospital queues, and writing production code. And what does that mean? It means this massive spending on AI data centers, custom silicon, and GPUs is mandatory. It's not optional. And by the way, that's before you even factor in the tens of billions more coming from Oracle and infrastructure ventures like Stargate. Now, all of that data center capital ultimately has to land somewhere, right? It lands on a wafer. The AI chip market itself, meaning the actual GPUs, accelerators, and custom ASICs running these models, is estimated to hit between $84 and $107 billion in 2026 alone. Multiple research houses are forecasting this market to grow at a blistering 28 to 36% compound annual growth rate. So we're talking about a market speeding toward the high hundreds of billions by the early 2030s. It's a trajectory going straight up and to the right, but that leads us to a pretty massive rhetorical question. What actually happens when this unstoppable financial growth smashes right into the strict, unforgiving laws of physics? To really answer that, we need to transition away from the macroeconomics and zoom all the way down into the microscopic reality of advanced semiconductor manufacturing. To anchor the sheer scale of this physical bottleneck, just consider this one number. Building a single leading-edge semiconductor fabrication plant, a fab, now costs between $15 and $20 billion. As we shrink chip nodes down toward 3 nanometers and below, just to get the performance per watt that AI absolutely demands, the fabrication process becomes dramatically harder and exponentially more expensive. And at these incredibly tiny nodes, just processing a single 3 nanometer wafer now runs into the tens of thousands of dollars. Think about that. When one single wafer costs that much, every fractional improvement in defect density matters immensely. A tiny, microscopic error doesn't just ruin a single chip anymore, it compounds across billions of dollars of downstream capital expenditure. This brings us to a stark contrast in how we handle manufacturing right now. The old way, conventional, particle-based cleaning, is just totally outdated at this scale. Standard cleaning only removes visible particles. But at 3 nanometer and 2 nanometer nodes, the real problem is contamination and disorder at the atomic level of the semiconductor interfaces. So the absolute necessity now is atomic level purification, which literally reorders and purifies the wafer surface right down at the atomic level itself. Which brings us to a concept called yield economics. When you're dealing with a $15 to $20 billion fab, yield is not just some niche technical detail for the engineers in the back room to worry about. No, it is the exact battleground where the financial viability of a chip is decided. Yield is the ultimate metric for success here. It is the literal difference between a highly profitable node and a written-down, totally failed one. And this is exactly the layer where SisuSemi operates. The solution, SisuSemi's atomic level purification, or ALP. Okay, let's look at the results of ALP in testing, because honestly, they are jaw-dropping. By intervening at the atomic level, SisuSemi delivers up to a 3 to 4 times reduction in defect density. That leads to up to a 70% lower leakage current, a 50% improvement in battery life, and, crucially for fab economics, up to a 20% increase in manufacturing yield. We're talking direct, massive economic and physical wins across the board. But what's incredibly strategic for investors to understand is how SisuSemi actually delivers this tech. It's done through their Atom Seal platform, which is designed to integrate seamlessly into existing production lines. It's completely compatible with integrated device manufacturers, foundries, and fabless companies, which means zero greenfield build cost. You simply plug it into the multi-billion-dollar fabs that already exist. It's a real game changer. Section 2. The picks and shovels strategy. This strategy brings us to what is structurally a much safer and potentially way more lucrative bet than trying to pick individual AI software or hardware winners. Look, SisuSemi does not compete for a slice of any single hyperscaler's GPU order. They aren't betting on one specific AI model architecture to win the big race. Instead, they act like a critical toll booth. They sell into the yield economics of advanced node manufacturing itself. That's the fundamental layer every single AI chip has to pass through to even be viable. And the capital markets? Yeah, they're already recognizing this uniquely attractive position. In just the first half of 2026, semiconductor-focused startups, and that includes materials, yield, and process innovation, drew roughly $10.7 billion in disclosed see-through pre-IPO funding. So there is immense market demand and financial validation actively pouring into the companies that are solving these foundational manufacturing problems. We can see a really clear picture of the strategic validation building up. Take Nanotronics, an AI-powered microscopy company that detects manufacturing defects. They raised $146 million, pulling in top-tier investors like Founders Fund with Peter Thiel personally joining their board. Then, in early 2024, OrbiMed made a strategic investment in them. We also saw Onto Innovation acquiring key product lines from Similab for roughly $495 million to strengthen their inline wafer contamination monitoring. Top-tier VCs are aggressively rewarding defect and contamination control tech. This quote pretty much hits the nail on the head regarding where the smart money is shifting. Deep tech investors are looking way past the chatbot hype on the surface. They are increasingly rewarding companies that sit close to genuine supply chain and physical bottlenecks, rather than pure software plays layered on top of them. The thesis is super simple. If you solve the manufacturing bottleneck, you enable the entire industry. So, to summarize the core thesis of our explainer today, AI's incredible promise, the massive productivity gains, the brand new product categories, and those $725 billion hyperscalers are betting, all of it depends entirely on building chips that are smaller, cooler, more efficient, and more reliable. And as we've explored, building those chips depends entirely on solving contamination and defects at the atomic scale. SisuSemi's ALP technology is built exactly for this moment. For anyone looking at where AI's massive capital supercycle ultimately has to spend itself to survive, securing a stake in its physical foundation isn't just necessary, it is the ultimate growth opportunity. Atomic-level purification is where the next disproportionate returns get made. So the final question you have to ask yourself is, will you be betting on the software surface or the atomic foundation that makes it all possible? If you found this breakdown insightful and want to understand how you can be part of solving AI's biggest physical bottleneck, the next step is simple. For more information, please contact www.sisusemi.com.